Welcome back and thank you for joining. We'll continue with the second part of the factor theorem lesson, and we're down to example number 5, where we want to factor completely y equals 4x4 plus 6x cubed minus 6x squared minus 4x. So we're going to start off by checking for greatest common factor. And as you can see in here, all the coefficients are even, which means that 2 would be a common factor. And another thing you probably notice here is that all terms will have a variable x attached to it. So x of the lowest power you see there will be common to all of them. And we'll figure out what is left. So if you take 2x out of 4x4, we're left with 2x to the power of 3. 6x cubed has become 6 divided by 2, 3. And then x cubed divided by x1 is x squared. Negative 6 divided by 2 is negative 3, and x squared divided by x is x, and negative 4x divided by 2x is 2, negative 2. So we have created our first factor, found the first factor already. That was nice and easy. Now we'll continue with the rest of the polynomial expression. We have a third degree polynomial, and the leading coefficient, as you can see in here, is different than 1. And we're going to look into the constant term for the possible values of b. So we're going to say that plus minus 1 and plus minus 2 are possible factors of b. And we're going to look into the leading coefficient of this polynomial to find the possible factor or values of a, plus minus 1 and plus minus 2. This will help us find the possible values of b over a. We always start with our b values, so plus minus 1 divided by plus minus 1. And then we get to plus minus 1, this time divided by plus minus 2. So we divide this number by each a value. And now we'll continue again with the next b value, which is plus minus 2, divided by the first a value plus minus 1, and then plus minus 2 divided by plus minus 2. Okay, I'm getting mixed up with these colors in here. And we have b here and over a. Okay, so in other words, we're going to say that our b over a values would be equal to, so we write them in simplified form, plus minus 1, plus minus half, plus minus 2. And as you can see here, plus minus 2 divided by plus minus 2 will give plus minus 1 again, so we don't have to list it twice. So thankfully, we don't have a lot of numbers that we have to try in here. So we're going to find the values of b over a that make this polynomial or give this polynomial a value of 0. So we're going to start with plus 1. So b over a equals 1. And that will give 2 times 1 to the power 3, 3 times 1 to the power of 2. And then we have minus 3 times 1 minus 2. Let's see what we get. We have 2, we have 3, we have minus 3, minus 2. Oh, that's amazing. So that's 0. So therefore, we're going to say that x minus 1 is a factor. So if x minus 1 is a factor, we're going to start our division by the factor to figure out the quotient, which will be the other factor of the polynomial. So we're listing these coefficients because this is a polynomial we're factoring at this point. So we have 2, 3, negative 2. We're drawing this half rectangle, bring 1 down here, and that is going to be this number 1 here. And we'll start dividing. Bring 2 down. 2 times 1 is 2, 3 plus 2, 5. 5 times 1, 5, negative 3 plus 5 is positive 2, 2 times 1, 2, negative 2 plus 2 equals 0. As promised, the remainder is 0. So that means that quotient here would be 2x squared plus 5x plus 2. And the factors of this polynomial so far are y equals 2x. We already got this one in the first step. We just got x minus 1 and the quotient as well, which is 2x squared plus 5x plus 2. We're going to try to check and see if we can factor further. So we want to factor completely. That's what it means to check if every single factor is in linear form. And I see that the coefficient a is different than 1 still, but the only way that you can write the first terms would be 2x and x, because 2 factors into 2 and 1 only. And the only way we can factor number 2 is 2 and 1 as well. So we either have 2 in here and 1 in here, right? Let's see if that works. 2x squared, 4x plus 1x. Okay, that works. But if it didn't, then you just swap them around. So we have plus 1 here and plus 2 in here. And this will be the factored form of our polynomial. Next, we're going to look at another question. I think this is an interesting question. We have seen this before in the previous lesson with remainder theorem. Let's read it together. When 2x cubed minus mx squared plus nx minus 2 is divided by x plus 1, remainder is negative 12. And x minus 2 is a factor. We have to find m and n, just like with the candidates. So m and n. Okay, so read the problem again to clarify what information you have and how it can be used. When divided by x plus 1, remainder is negative 12. So what does that mean? It means that the value of this polynomial at this b value, what is the b value in this case? Well, it has to be negative 1, so we must subtract it negative 1 from x to get x plus 1. Must be equal to negative 12. So we got that. Now, the next piece of information states that x minus 2 is a factor. So what does that mean? It means that at x equals 2, the value of this function will be equal to, if it is a factor, 0. So we're going to use these two statements into this equation to find both unknown coefficients. So we have 2, negative 1 to the power of 3 minus m, negative 1 to the power of 2. And then plus n times negative 1. And then minus 2 equals negative 12. Let's simplify. So we have negative 2. Negative 1 squared is 1 minus m. These two will make a negative n. Minus 2 equals negative 12. So negative m minus n equals negative 2 plus negative 2, negative 4. To the other side, positive 4. So that makes the right side negative 8. Simplify some more. M plus n equals 8. This will be our first equation that relates m and n. Now, f of 2 is 0 means that 2 times 2 to the power of 3 minus m times 2 to the power of 2 plus n times 2 minus 2 equals 0. I think we need to make a little bit of room here. So let's check and see. Simplify. We have 2 to the power 3 is 8 times 2, 16. Minus 4m plus 2n minus 2 equals 0. So negative 4m plus 2n equals Remember, 16 minus 2 is 14. To the other side, negative 14. And let's divide both sides by actually negative 2 would be nice. You see, we can make the first term from negative to positive, and most terms will turn positive and reduced. So we have 2m minus n equals 7. This will be our equation number 2. We'll put these two equations together. I really like how they look, and you'll see why. We have 2m minus n equals 7. Notice how, the n and negative n have opposite signs. We can easily eliminate n. We have 2m plus 1m is 3m. N minus n is no n, and that would be equal to 8 plus 7, 15. So m equals 5. So if m plus n equals 8, and m is 5, that will make n equal to 3. So therefore, we're going to say that n equals 3. So the answer will be m equals 5 and n equals 3. This is a typical quiz test question. It's not too difficult, but it does involve a lot of multiple concepts from the remainder and the factor theorem. So I hope this made sense. And as always, thank you for learning with me. And bye for now. See you next time.